In today's episode of Open for Business, we're going to speak with Laurence Bleicher. Laurence is a fascinating guy who has a background in mathematics and a master's degree in aerospace engineering, and he's taken that background, he's created this business called Energy LB Resources. Energy LB Resources is about optimizing electrical systems. Well, we're going to explore that and find out just exactly what that means. Laurence, thank you so much for joining us here at Open for Business today. I would love you to start off by please telling my audience just exactly what your background is before we even tell them anything about what your business specifically does and what you specifically do. Give them a little bit of your background. It's really fascinating.
All right. I am an engineer by profession. I studied mathematics. Later on, I studied aeronautical engineering in grad school. Entered a career in high tech. For much of my career, I was involved in various aspects of the telecom industry. Early on, doing a lot of algorithm development. This was mid-90s, late 90s, when the whole concept of converged networks was being realized, and people started we can stream audio and video and data and everything over the same networks. So video encoding and noise cancellation and echo cancellation and all kinds of algorithms for things like that, and later on got very involved in just embedded software architectures, things like that, for doing all that switching and processing underneath the hood that nobody thinks about until you have to think about it. Moved on from there, spent a few years doing automotive technology, where I was involved in radar systems, smart safety things, collision detection and object detection, things that are now essentially becoming standard and ubiquitous on cars. So 10 years ago, again, that technology was being born and realized, and lots of different avenues and methodologies were being experimented with. And so I was involved in that a little bit. A very little bit consumer technologies and things like music and audio processing, but only a little bit of that. So 20-year career in high tech. And then for a variety of reasons, I decided to go my own direction. And we can dive into those reasons if you want to in this interview, but that's really another discussion. And so about 6 years ago or so, I looked into doing various things. Energy, because, one, it's just fascinating. I mean, even then, and for really the last couple of decades, but I'm getting ahead of myself. But now the business models are catching up to the technology a little bit. But we're in the middle of this fascinating and huge transformation. About the way we think about energy, the way we use it, the way we transport it, the way we sell it, the way we generate it. All those things are changing rapidly. Technologies and business models and revenue streams are all opening up in the clean energy arena. So I thought it was a fascinating place to be. And so I ended up starting this business in 2014, technically, but we really didn't go into operation until a couple of years later. Energy LB Resources.
So Energy LB Resources, we think of energy and we think of power, we think of our cars needing gasoline and things like that. That's not exactly what you're doing. Give us a description of what Energy LB Resources is. Who's your market, and more specifically, first off, what exactly do you do?
What do we do? So we are an engineering company, fundamentally. Mm-hmm. We are focused on energy efficiency and power and resource optimization technologies for CI customers, commercial and industrial customers. Mm-hmm. It's not a residential play, although, we may morph more in that direction going forward, but for now it's not a residential or small. We're talking about big buildings. And what we do is we have a suite of different technologies with which we want to take existing equipment and existing operations and existing energy use. And energy is a very wide word, and I'll get into that in a minute. I say power and resource is really more accurate. And get all those operational aspects of running a big building, whether it's commercial, whether it's industrial, to run better, to run more leanly, to reduce consumption, obviously, to mitigate demand curves and spikes, to have everything run cooler and more efficiently so that equipment lasts longer. You get more out of if you're purchasing paying utility bills, whether it's electricity or natural gas or propane or water, is another resource that's too often underlooked, in fact, as a power source and as a power resource. You're paying for all that. So where's your money going? Are you spending it wisely? It's one of those things where your pain isn't always visible. You get the electric bills, crap, that's high. And then it goes to accounting and it gets paid. And people don't realize, oh, wait a minute. And I always use the metaphor, think of a compressed air system. If you can hear a leak, you can feel that the pressure in a given device or a pump or whatever is not performing well. You can feel and hear that, and you'll go and you'll rectify that. Well, electricity, it's not always as obvious or visible, but the same types of distortions and inefficiencies occur, and we can rectify those.
Okay, so let's do this by example. I took a look at your case studies, and some of them were really fascinating. One that really caught my eye initially was the West Fraser Timber Company.
Yes.
And I couldn't help me. My eyes went right down to that that baseline voltage and unstable
Yes.
voltage graph that you had there. Now, of course, just to let the audience know, and most of the people who know me know that I have a background in engineering, so I can be a nerd from time to time. And so that definitely caught my eye.
What are you the rest of the time?
All right. I admit it. I'm a nerd. But I'm curious. Use one of your case studies to give the audience a nice foundational example of the set of things that you might look at when you go into a company, a large building, a large facility. I'm
actually, in my mind, I'm going to use a different lumber mill that we did locally here in New Hampshire. And we went in, and they were having two issues. One, costs. Cost cutting is always a motivation. No, very few business owners or managers will say, no, I don't want to save money. Now, how much it costs to save money, that's a different question. And how can we implement that? That's a different set of questions. But, cost cutting is always a motivation. Beyond cost cutting, though, and beyond just saying, I want to reduce my power bills. And this is by and large electricity. It's a lumber mill, so there's not a lot of heating. There's not a lot of air conditioning, some lighting, kilns and steam, and that is one relatively limited aspect of the operation. So we're talking about boilers and steam is one subsystem, and electric power distribution is the other. Talking about the electric power distribution system, one, just to cut costs, but two, they were having a lot of problems in that they couldn't keep up with their production objectives. They just couldn't process enough wood, at least at certain times, that they had hoped to or expected to or needed to. And some of the problems that were preventing them from doing so were what they considered mechanical problems. Saws would warp, or linkages would break, or motors would overheat, or trip a breaker, or a variety of problems. And in their minds, it was much electric problems were one thing, if a breaker, and mechanical problems were another. But when you really go and take an integrated approach and an operational approach, you realize mechanical problems are often power quality problems, because if a motor sawing through a big 6-foot tree, a log, doesn't have the torque that it needs, it's going to start sweating, it's going to squeal, the saw is going to heat up, and then of course you get physical distortion and torsion, and things break. That's a power quality issue. So if we can mitigate some of those, is reduce some of those kind of challenges, then that's money, because they can increase their production and they don't have to spend as much maintenance and repair and replacement expenditures. So in the case of lumber mills, and the one you read about in West Fraser too, is in a bigger example, that they didn't start from, I want to save my, I want to reduce my energy bill. They started with we have all these problems. How can we get our operations to run more efficiently? And so that's where energy and energy efficiency and operational scheduling kind of get married up. So did they have any idea that power in that lumber mill that you were just describing, did they have any idea that power was the issue, that dirty power or fluctuating power was an issue? Any idea at all? Or they just find you and they said, help us figure this out? Yeah. I don't want to go so far as to say they had absolutely no idea, but I think it was more of a mystery. They were starting to think, oh, why do these things happen as often as they do? And it couldn't just be because the saw is bad, or the blade is bad, or the motor's old. Sure, those are all factors that can contribute to problems, but they were wondering why. Now, they didn't really make the connection that, oh, these could be power and electric distribution network issues that we could address. And I don't want to get too much into technical weeds here, but it's about voltage stabilization and reactive power in a network. And I don't know if you want to go into a reactive power right now, but I often use a metaphor of a bicycle when I explain these issues to people. The bicycle being, if you're suddenly going up a hill and you're putting in the power that you're putting in, but the more power that goes into just the chain is stretching and the pedals aren't quite balanced and the frame of an old Schwinn lousy bike is torsioning, then all that energy is going to not productive work. Whereas if you have a nice $8,000 beautiful new racing bike from Cannondale or Specialized, then more of the power you put in is going to go to actually turning the wheels. And the similar thing happens, and that's where reactive power comes. You want to get rid of all that stretching and contortioning so that the power you put in actually does productive work. And that's how we can stabilize electric networks.
Mm-hmm. Are you getting calls from, and do you work with companies that are across the country or in a particular region? How do you sort that out?
Yeah, we can. I mean, we are based in Nashua, New Hampshire. So just by sheer geography, our radius sort of begins here, and we've done projects. All of our projects to date have been in New England. Obviously, most of them in New Hampshire, a couple in Massachusetts, one or two in Maine. Having conversations with entities in Vermont as well. But we can and will go anywhere, where there's an opportunity and where there's an issue to be faced. If it's worth it and warranted, well. Right now it's been difficult to get on a plane, but in principle, we'll go towards opportunities. I grew up in the Midwest originally, so I'm familiar with it.
Yep. So take, for example, I'm in an office building here, and there's actually two halves to this office building, chillers on the roof, the whole classic type of building infrastructure for power and heating and ventilation and things like that. Is this type of building something that has some of the issues that you're talking about as well?
Yeah, potentially. I mean, obviously it doesn't have the energy density that a manufacturing setting would have, but infrastructure is still expensive. HVAC, heating, cooling, lighting, air movement, and water are still, they're expensive propositions and difficult to maintain. So potentially, absolutely. And we can look at, you mentioned rooftop units. Yeah. The traditional big, 20-ton unit, 30-ton unit for a big building, usually a few units like that on the roof or outside. I mean, you can get more cooling capacity out of that refrigerant by adding special additives. You can coat the coils and reattach the fins to the actual coil so that the thermal heat transfer again is augmented. People don't realize, everybody's seen a bunch of coils and there's dented and there's crud in there and the fins are bent. Well, that's costing people money. So just the knowing what to look at sometimes can be hugely beneficial. For larger installations and really big systems, there's more sophisticated technologies to look at, like evaporative cooling for chilling systems, where you have a panel that's spraying a fine mist controlled by temperature and humidity outside the condenser coils themselves. And so if it's a 90-degree day outside, the evaporative process absorbs heat and the coils see only a 70-degree temperature. So the delta between where they are and where they need to get is much smaller. They don't have to work it hard. That reduces the duty cycle. That's money in your pocket. Things like that. On the heating side, likewise, we bundle technologies together. Can I give an example?
Please do.
We're working with an assisted living facility now, way up north in northern New Hampshire. And we did LED technology we did a year ago and put in some lighting controls. They've saved a lot of money. And we were going to do, or we're just getting into it now because of COVID, but they heat the whole place with forced hot water. So they have a bank of boilers burning fuel oil number 2 and then forced hot water throughout the facility. So we're combining and bundling together a suite of technologies. One is fuel enhancers to improve the grade of the fuel oil. With any carbon-based fuel, you can improve. It's like improving the octane in a gasoline. whether it's diesel or fuel oil or natural gas or propane or any fossil-based fuel, you can break down the CH chains a little bit and get more efficient burn. You simply get more for your money, improving your mileage, so to speak. That, together with their water system, again, people look at water and they think cleaning up the water is a health issue, which is true. Of course, people think about Legionnaires and things like that, but it's also an energy and power issue. If you get the water clean and can filter out a lot of particulate matter and contaminants, you're going to get more thermal heat transfer property out of that water. And stuff doesn't build up on the pipes as much. So doing that, and so there's a variety of ways we can do that. There's a water technology we have which emits an electromagnetic pulse through the piping. It ionizes the particulates a little bit differently so that they don't bond to the pipes, and then they're suspended. You can filter them out. Your water stays clean. You get more heating out of the hot water, as an example. So that kind of gives a really good flavor of what you asked in the beginning. What do we do? What do we offer? We're pragmatic, science-based technologies bundled together, which people aren't always obvious on everybody's, oh, what can I do for energy efficiency list? Whether strip the building, get a better motor. We're looking at the operations and the resources themselves, the gas itself, the fuel itself, the water itself, the electricity itself, and trying to improve them. Of course, if we see an old motor that's just past its prime and it's worth it to spend, then we'll recommend get a new motor. If we see a hole in the wall, we'll recommend fix the hole in the wall. But we're not a product rep. We don't go in and wanting to sell you a new motor or sell you a new HVAC system or an air compressor or whatever.
So in your travels of doing this, I would imagine you've seen designs that you must sometimes shake your head at and say, why did they make this choice? Why did they make this decision? So just to give you a little background as where that comes from, I used to own an architecture firm.
Yep.
So I've worked with civil engineers, mechanical engineers, and I'm wondering if you get called in by those people who are doing those designs, and I'm talking on larger facilities,
yeah,
who are doing those designs, because the worst nightmare, of course, after a building is completed is where the people in that building are going, I'm freezing, I'm too warm. This side of the room is 100 degrees. This side of the room is 55. Those are nightmare scenarios and very difficult to fix post facto.
Yes.
So I'm wondering if someone like you who's seen such a wide variety of things that have gone right, things that have gone wrong, things that need to be fixed, other technologies that can be brought to bear. If you get brought in by some of those mechanical engineers
Yep.
who are designing these systems, for your input?
There have been examples like that. There have been cases like that, but it wouldn't be accurate to say that's really how and why people reach out to us. Okay. I would like them to do so more, and to use your example of it's freezing over here and it's hot over here. More to expand on that a little bit, what we see surprisingly often is that the air conditioning and the heating are running at the same time, or at least in different zones. They're competing with one another because one's a production area and one's an office area, and it wasn't well designed or it wasn't thought out. If we put thermostat set points here and the production areas need a certain humidity there, so we lower the temperature, and then you have these systems and you get the point. So things like that we try to address, but to directly answer your question, no, that's really why people reach out to us. People reach out to us more in the, I don't understand why I'm spending so much on my power and resources. I don't understand why my fuel bills are so high. What can we do?
Sure.
That's really the bread and butter of how people get to us and why you typically.
Right. Got it. So let me back you up now.
Yep.
So you've given a really nice explanation of the different types of work you do within this energy resources area. I am curious, and I do need to ask you the question: what on earth made you move from what you were doing into starting something like this? There's usually a good story there.
It's a story. There's a lot of good stories, actually. Well, I mentioned I spent 20 years doing the high tech thing and enjoyed a lot of it. I enjoyed the technology. I still enjoy the technology. I miss that kind of sense of let's invent something new. How can we process this data differently? Although we're still involved in that to some extent. But long story, very short and condensed. I found the high-tech workplace less and less enjoyable as I grew in my own career for a couple of reasons. One is things got very commoditized. And by commoditized, I mean more and more the business became about mergers and acquisitions, projects or small companies or startups or wings of bigger companies would get purchased and bought and sold and stop a project and start a project and start a project and stop a project. And it was frustrating that it became much more rare all the time to actually be able to bring a project to completion, to fruition because of that. Two, on the technical side of that, it more and more often became stitching other people's software together. And as an engineer, that it started to feel like, I like metaphors, right? Started to feel like a mafia candy store where we were selling candy in the front, but the real business was going on behind the curtain in the back. That was the craps game, so to speak. And the engineering wasn't really what they were after. They wanted to bring a company. What are our numbers this quarter? They want let's get our market cap to be this much, and then we're going to sell it. I was less and less interested in playing that game. Why? So that's why high tech. I should say that's why high tech became less and less of a where I wanted to finish the latter chapter of my career. Why an entrepreneur? I just there's a lot of personal reasons, but just felt ready for the challenge. I felt like it would be interesting to create and bootstrap something from nothing, and we have been able to run the business pretty old school in that sense. We're not being run by angel or venture money right now. It's all what we could scrape together ourselves and what we could borrow. And it's, and that's exciting. It's been a challenge. Obviously, I'm not, I'm learning to be an entrepreneur and I'm learning to be a salesperson. And it was a hard lesson for me to learn personally. Talking to my business partner the other day about this, I had to learn that I'm no longer an engineer. I'm a business guy. I'm a salesperson. Even when you're not out doing sales, but I own a business, I'm a salesperson. That's a transformation that I have to go through. But the last part of the answer to your question, I guess, is I mentioned this earlier a little bit. Energy is fascinating. I mean, it's not just about, let's be green, which is important. I mean, we need to all be, but if everybody in the state of New Hampshire, if everybody in New England could right tomorrow stand up and say, we reduced our energy consumption by 3%. Or 5%, everybody would stand up and cheer. I mean, that would be an amazing accomplishment. So when we go into a facility and say we can reduce your bills and consumption by 8%, and we can reduce your maintenance on these by another 12%, and we can do it all for a payback period of less than 3 years, that's a compelling story. I want it to be a compelling story. It's compelling to me, and so to mix that business play, it's about operational profitability. If you look at it from the money side of things, it's operational profitability. Whether you cut costs by buying a cheaper part or reducing your energy or having your operations do more work for you in the same amount of time, they're all related. And so I find it a very dynamic space to be in, both technically and financially.
Sure. How many people are in your firm?
That's an interesting question. Well, so I guess I'll answer the question, but I have to give a little background on the business. So we began and are still primarily, although not totally, what we call an affiliate company of a larger company called Energy Integrated Solutions. They are based in Atlanta. They've been doing this, for 40 plus years now. Energy conservation measures, pragmatic energy efficiency solutions. Mm-hmm. What does it mean to be an affiliate company? We're not a franchise. We're not owned by them. It's much akin to an auto dealership. I can go to a Honda dealership here in Nashua, and everybody knows that Mr. So-and-so, that's a Honda dealership, but he's not an employee of the Honda company. He's a businessman. He also sells some Volkswagens and some motorcycles on the side and does some other things. He's not only selling Hondas, but everybody associates that business with the Honda Corporation. And of course, he gets marketing material and demos and back support from corporate. So it's very similar. We do other things, and I have suppliers who are not attached to them in any way. But what I like working in this family of affiliate companies with them, because they have a whole very broad and diverse set of tech partnerships with various companies doing interesting energy efficiency technologies. People in Montreal doing winter climate technologies, like issues with heat recovery and steam systems. Other people in other areas of the country doing real-time power rectification, volt, optimization and things like that. Every tech partner of theirs is a tech partner of ours. So I have access to a lot of expertise and a lot of engineering. So when we do a project locally, I can bring to bear engineering expertise and resources and design efforts based on a lot of experience in the field, whatever the particular area needs to be. And so it's a good position for us to be in, because we can't. My background is aeronautics and EE. Can't be experts at everything. I'm not an expert personally in water systems, but I work with people who are. So that's generally where we fit in. We also do other things independent of them. To answer then your question, how myself, a business partner, I have a couple part-time employees now, but by and large we hire people, contracted people, because it's a very, very much a project-driven business cycle for us. So when we're in the middle of 2 or 3 projects, I might have a stable of half a dozen different contractors that I rely on regularly to do the work. But then those projects end. And so they're not permanent employees of ours. We hire them on a 1099 basis. I have a couple different contracting firms who we partner with regularly. Electrical contractor who I know the owner, and we do most projects together if it involves electric work at all. And I partner with other people who do building envelope stuff, because that's a natural marriage. We don't deal so much with the chassis of a building like insulation or air sealing, but that's a big part of the energy usage puzzle. So I often partner with 1 or 2 other companies as we approach opportunities.
So it sounds like this business model with EIS, it sounds like they're kind of at the hub of the wheel, and they provide you access to other firms that are doing what you're doing, but might have expertise in other areas.
Right.
Gives you a referral network.
Right. And I don't want to get too much in all the different business arrangements. I mean, there's some things I will deal directly with them in terms of purchasing product and things like that. And there's other things, as we've gone through and developed more and more close working relationships with some of these other technologies that we deploy. Obviously, we've gotten to know their engineering and their owners personally. And so, and more we develop, and we have relationships with the technology developers of all these different things. The last thing I would mention is that we're also developing a little bit of technology of our own. We have a couple of R&D efforts. I can't really speak to them until we have more of a product, but it has to do with throwing data science and a little bit of machine learning. We collect tons and tons of data. Sure. Right now, it's a very manual process. We have all this data and we bring it into some software. You can look at all sorts of visualizations across a week or across 20 milliseconds to see what a network is doing. But to automate all that and to have machine learning really discern patterns. I mean, the holy grail for us is I want to be able to go into a facility, hook up some loggers, have it be automatically uploaded to a server, whether it's on site or the cloud, it doesn't matter. And then come back in 4 hours and say, well, while we've been doing inventory on your lighting, oh, look, the software just said that you could have saved $311.14 in the last 4 hours had you taken the following actions with your electric system. And that's where we're going, is to have AI and machine learning of today be able to process all this data we gather and to have much more rapid designs, but much more optimal designs as well.
That is also a very scalable model.
Yes.
Allows you to grow very differently. I go in and consult and contractors and whatnot is this and that's a that.
Right.
Right. That's
right.
A very different model. That's really interesting. So that kind of goes to my next question is where are you trying to grow to? Where do you want to take this business? What's your mind's eye?
What's our mind's so many different things.
Great.
But I just mentioned one of them. Obviously, we're developing this layer of technology, which is really bringing data science into what we do, bringing machine learning into what we do. And the broader conversation is, look, industry is changing. People talk about, in Europe, it's called Industry 4.0. In the United States, it's often called the Industrial Internet of Things or Smart Industry, whatever nomenclature you want to use. everything is interconnected now. Your doorknob has Wi-Fi and Zigbee and Bluetooth on it. I mean, everything is going to be able to share and process data. And so we want to be part of that conversation as we go forward with it. And people talk about energy efficiency. Energy efficiency is, like so many things, going to change along with these paradigms. Energy efficiency is really going to be discerned on a much finer scale, and as well as a much grander scale, because we can process so much data concurrently. Where is your money going? Where is your energy going? And all that data will be able to discern when things are starting to slide, and much more optimally than what's possible today, where you have P to F curves and you start to degrade and you get an alarm when something isn't performing quite right. And that's come a long way in and of itself. But the possibilities are endless for the system to know when it's performing or not performing well. So that's one huge trend. And the more practical sense, in the next couple of years, we want to continue with these partnerships. We want to expand. We want to bring energy efficiency into the forefront of entities' minds and their plans about it's not just, and actually this is a good segue to where I started in the beginning. It's not just about getting a better motor, or, oh, that window seal is broken, let's weather strip it and get a better window seal. Those things still need to happen, of course. But energy efficiency, you have to think in terms of all these different resources that are going into all these different sophisticated technologies and pieces of equipment today. And think about, all right, poor energy efficiency is causing that recirc pump to underperform, or poor usage of our fuel that we're purchasing is causing that particular boiler to not regulate its pressure carefully. All those things are energy efficiency. It's not just about, all right, I want to have less air leaks in my building, or I want to have my SEER rating on my air conditioner to go up to 95. The old model was 88. Those are still true, and you want to look at those ratings and the ability of the equipment to perform well at a high level. But you also have to look at how all those equipment, whether it's performing well or not performing well, how they affect your production and your profitability and your maintenance schedules. All these things are interrelated. And so that's kind of where we want to be, is bringing, and that's why I'm very careful. People talk about energy efficiency, but we use the buzzword optimization. We want to optimize people's energy use, and optimize in a lot of different ways, not just, I want to reduce your bills because we can use a little bit less. So
are you marketing to, or trying to get your story out to, facilities managers or building owners? Who are you trying to get this message to?
Yeah, that's a great question. Well, there's usually two people whether it's an industrial setting, like a factory or a plant, or it could be converted mill buildings with a big commercial settings, could be hospitals, could be grocery stores. Grocery stores are a small but interesting example in that they have to they have to cool and freeze their food and store it even in the coldest seasons. It's very energy intensive. So in all those cases, could be cold storage facilities. In all those cases, we want to talk to two people. One is obviously the people who deal with the facilities and the equipment, whether it's a plant manager or a store owner or whatever the case may be, property managers, but also the people who own the P&L budget for where that CapEx expense is going to come from. I say the CFO. It doesn't have to be the CFO. I want somebody in that office or somebody in a particular division, if it's a larger company, who owns that operational and capital budget, because that person has to be on board too. Again, it goes in concert with what I was saying a minute ago, how it's not just, oh, I'm dealing with the motors. That's not a financial thing. It is a financial thing. Your cash flow projections across the next 3 to 5 and 10 years will look far better if you make some operational improvements in how you're using the energy. And so those two wings of the company or individuals within an entity kind of have to work together. So we try to do a team approach and say, these are the people who need to be the stakeholders in this conversation.
And how, right now, in the phase of growth and development of where your company is, how do you get that message out? What are some of is it all word of mouth? Is it Is there
Yeah.
an established system and process that you have in place? What do you do given your phase of growth?
A couple things. Lots and lots and lots of networking. We try to be members and active members of various organizations in any given year or period of time. A couple different chambers in different regions. We rotate through. It's not always the same ones, but a couple different chambers. We're members of Clean Energy New Hampshire, which is I don't know. I can explain what that is, but they're a consortium and an advocacy group who deals with the clean energy agenda. A counterpart organization is E2 Tech in Maine. Very similar. It's sort of the main counterpart to the same thing. And each one of these organizations have lots of different tentacles and contacts and circles of people who are all thinking about, we need to change our energy climate. We need to change our literal climate, but the two go together. And so lots and lots of networking events and contacts like this, and getting our word out. Before COVID, we did, we would exhibit and participate in various shows, whether it was municipal efforts to make their cities more green and more energy lean. And of course, obviously, a lot of different trade shows and things like that, different circles. That came to a grinding halt. We actually were growing, we were starting to ramp up as a small company and grow in the latter half of 18 and 19. We were doing well. And then COVID happened. So it's been discouraging this year, just because part of our process is to do a really deep dive analysis of facilities. Sure, we can exchange information online and we can talk to people, but there's no substitute for actually being physically in a facility. And that obviously slowed down for a few months. It's starting to pick up. Well, it was starting to pick up now. Who knows what's going to happen in the next few months. So we've had to, like so many other small businesses in so many different fields, we've had to learn to adapt. So more and more of online networking. It's not the same, but that's the world we live in.
Good, excellent. If people in my audience here do want to get in touch with you, what would be the best way for them to do that?
Best way. Well, the easiest way is on our website, which is energylb.com. That's the word energy. L is in lake, B is in boy.com. And there's a contact page, and an email will come to myself or somebody in the business. We're pretty responsive. We're still a fairly small company, and so we'll see those emails within a day, and we'll respond immediately. That's the easiest way. Certainly, you can contact me. Our number is on their website, of course, but for anybody who's hearing this, it's 603-275-7238 is our work line. Give us a call. Most likely, it'll be me that answers that number. Possibly somebody else, but you'll get me, and we'll begin a conversation. That's the easiest way. I mean, I don't know if you want the full contact specs or LinkedIn or anything, but that's enough.
Well, we'll put your name and number out for people.
Okay.
We'll do that for you. So thank you so much. But one of the things that this demonstrates, and why I really wanted to speak to you, is that they're all different kinds of businesses. You have found I'm going to call it a niche. You've found a niche that utilizes your background, your experience, your engineering side, your computer science side, these different pieces, and are making a difference in many companies out there. And I applaud you for making the shift that you did. It's not easy, and I wish you the very best in the future. Thank you so much for taking the time to share.
You're very welcome. And I want to mimic those words too. I appreciate these dialogues that you put forward, and I appreciate your taking the time. And it's one more way that we can be a business community with the common goal of getting new and interesting things out there. So I much appreciate it.
My pleasure. You take care.
Thanks a lot. Take care, John.
Thank you.
Bye-bye.